Okay, welcome everyone. This is actually the first regular webinar of the quarter. We've had our orientation, but this is a webinar where we actually do statistics instead of just kind of talk about how the class is going to work. Welcome. And again, the plan is we'll spend about an hour and a half or so. I'll take questions throughout. So please feel comfortable to either post a question in the chat box or to unmute yourself and then ask a question. And then I'll be happy to answer the question also. So let me tell you the plan today. I'm going to share my screen so I can give you my agenda. Which is, I think it's that one, but the agenda will come in a second. Okay, so here's the plan of the day. I'll start out, always answer any questions you have. I'll always put Q&A there. And even though that's number 1, it's also number 2, 3, 4, 5, and 6. So feel free throughout to ask any questions you might have. And then after that, after I go over the agenda and maybe answer a couple questions, we're going to get to a survey, because that's really what this class is about, is to understand data collection and how to analyze it and taking a look at it. Now, of course, we're not doing everything today because there's only week 1, but we'll talk about surveys. So I'll give you a very specific example of a survey. And that's what I like about this class so much, is that it's so easy to just go online and find some article or a current event that's going on and take a look. Then we're going to get into statistics and parameters. I know you think statistics is just the name of this class, but it actually has a meaning. So there is a statistic, and many of them are statistics, and there are parameters. And we'll talk about the difference between the two of them and some types of statistics and parameters. Then we'll get into sampling techniques. We'll kind of do that with the survey also, by the way. We'll get into sampling techniques. How do you best decide what data to collect for your study? That's what this is all about. And then after that, we'll look at measures of the center and the spread. So these are special statistics or parameters that help you understand the data or the population. And then finally, we will get into diagrams. So in particular, I'll go over histograms, which I'm sure you've all seen histograms, but I'll talk about some of the details on what histograms do, what they're good for, what they're not good for, when you're going to present, etc. And then we'll get into the stem and leaf plot, and that's a different kind of diagram that shows the data. And then we'll get into the box and whiskers plot, which is another diagram that shows the data. I can't do everything. Okay, there's no way in an hour and a half I can cover every possible plot and every possible statistic and every possible parameter and every possible sampling technique, but I'll give you the main highlights. That's the plan, and that's going to be the plan pretty much for every webinar. This particular day isn't going to look much like math that much. There's going to be some numbers, but not, it's not going to be very mathy. But later we're going to have a little more math to look at. Right now we're going to mostly just look at sampling and studies. So are there any questions about the class, things that have come up while you're starting out, or about anything else? So I always have one eye in the chat box and one ear on the microphone or the speaker. So any questions about anything? Okay, I do want to let you know that if you got an email from me that says you didn't watch or if you didn't do the orientation, then you need to take that seriously, okay? It's pretty hard to pass this class without having satisfied the orientation. Most of you did, but there are about 5 or 6 of you that that need to watch that orientation, take notes, and email them to me. So if I emailed you back after you emailed me, then it's done. We've done it. But there's a few of you still, about 3 or 4 of you that I'm still waiting on. So it's really important, or you pretty much won't pass this class, because there's a big penalty, 15% for the whole course grade. So you can't get an A. You really almost can't even get, it's hard to even get a B. Good luck getting even a C. So it's really important that you get that orientation. If I didn't record you and I emailed you saying I didn't record you, you need to make that happen, okay, with the notes. So that's a big note. A couple other things to note, and because I think I didn't mention it in my first orientation, and that is even though the initial post of your discussion post assignment is due on Saturday, I give you a special extra if you can do it by Friday. And that is that if you do it by Friday, I look at it, and if there's any mistakes in your initial post, I'll let you know so that you can fix them and not lose points. So I strongly recommend you always post a day before it's due. So normally that'll be Wednesdays, but again, this week is weird because we're starting on a Wednesday. So in this case, it'll be Friday for the day before it's due. So I recommend doing that. After this webinar, you'll be ready. So that'll give you a whole day to do that. So hopefully you'll be able to do it. It doesn't take that long to find an article. This particular one, there are so many articles out there that do what you need to do. Any questions? Any questions? Okay, it's hard to go wrong, by the way, on the 2 truths, 1 untruth. You know, that I don't think I've ever looked at someone and said, no, that wasn't okay. You know, it's pretty hard to go wrong on that one, as long as you post it, but you got to post it. So don't forget to post it. That's like freebie points. Okay, any questions at all? Okay, if there's no questions, what I'm going to do, and I know not all of you are local, but that's okay. You have your local news also, but I figured I'd pick out a local news article and talk about it.
Hey, Larry,
And
have you started recording yet?
oh, have I? Let me see. Just a minute. I think I did.
I heard the alert in the beginning. I think you did.
Yeah,
Okay.
you did.
Yeah, I did. It says pause recording. So yeah,
Alright,
if
sure.
it lets me pause recording, I must be recording.
All right, thanks.
Thanks for reminding me. And by the way, that's true of everyone. If I ever forget to record, please remind me. Okay, it doesn't happen that often, but every so often I'll forget. So if you ever don't hear this meeting is being recorded, then please remind you to hit record so that it's up there, and then I can put it on YouTube. If it's not recorded, I can't put it on YouTube because it doesn't exist. But thanks for reminding, Braulio. But I did this time at least. Okay, so let me go ahead and go to the Tahoe Daily Tribune, which is one of our main news places. And when I first got here, that was the newspaper. That's kind of obsolete now. They don't do paper on anything. Now it's, online news, but same thing. And again, I'm not going to read the whole Tribune, but I want to go scroll a bit towards the bottom. And there's the recent poll. So here we have it. And it says, what should the newly elected South Lake Tahoe City Council focus most on for the next 2 years? Finding a second economy, affordable housing, street repairs, connecting with minorities in the community. So here's what I want you to do, and you can put it in the chat box. Tell me what you think would be best for them to talk about. Even if you're from out of town, it matters to every town. So let's see in the chat box. Boy, it's almost unanimous. Okay, I think I can put affordable housing and say that's our class's decision. I'm not seeing anything else. Wow. Okay. Okay, well, police force for one. Let's see. That wasn't even a choice. Okay, so I'm going to click affordable housing and I'm going to vote. We do have the street repairs, but sorry, you're voted out on this one. Almost everyone was affordable housing. Okay, so I'm going to hit affordable housing. I'm going to vote. Okay, so here we go. So what we have is affordable housing, 34%, street repairs, 34%. So by the way, our class is not representative of everyone else that did this study because we were vastly affordable housing. And almost everyone else was affordable housing. Finding a second economy, I didn't see any of that. Connecting with minorities in the community, didn't see that either. But there weren't too many in the overall. Okay, so I want to look at this. And here's what the Tribune tells us. This is what Tahoe says, right? again, we just did our little group, but this is what Tahoe says. You trust it. Do you think this really does say what Tahoe thinks is the most important thing that the South Lake Tahoe City Council should focus on for the next 2 years? Do you believe that that's what that's what the South Lake Tahoe people think so? Okay, you say it's a small sample. Okay, it's not a giant sample, but it's not that tiny. If you look at the number of votes, there's 366 votes. And if you're not from Tahoe, I will tell you, we're not a big city. We have 20-something thousand in our city. Okay, it's actually not that small. Okay, it may feel like it, but actually it's not that small a sample. Okay, but the question is, does this represent the town or our city, or does it not represent our city? And what do you think? Okay, can someone vote more than once? That's a maybe. I doubt anyone is gonna like do that on purpose to be mean, because there's nothing you get out of this. This is a fun survey. How many people read the newspaper? That I don't know. I can't tell you. But do you think that you trust this? Like if you were in the city council, okay, and by the way, I have some friends in the city council. So if I needed to go talk to my friends in the city council that I've worked with, I don't know, I guess I haven't told you, I decided not to put that in my two truths thing. I was a politician for 9 years. So just to let you know, that doesn't mean I'm evil, by the way. So I do know a lot of the city council people. So if I went to the city council, and should I tell them this is what Tahoe thinks? Because here we got our study, and I'm a statistics expert. Okay, and what's the problem with it? Anyone see a problem? Yeah, it could
There's
be
limited topics. Sorry.
Okay, limited topics. They did kind of pick the main things in Tahoe. I don't know if you live in Tahoe, but those are kind of the main things people talk about. If you don't live in Tahoe, you wouldn't know that. But if you do live in Tahoe, those are the main things. You live in Tahoe, those are the main things people talk about, aren't they? For the city council. But do you trust this? Not that these topics, but do you trust that this is the way Tahoe thinks based on this survey? And I see some of you say bias. Why is there bias? Where's the bias coming from? Okay, it's only considering those who voted. So do you think those who voted are different than the regular population? And that's a big question. And that's the big question of the day. Okay. So Casey, I'm gonna, you said something very important, but you were off by a little bit. So you said it's a convenient sample, and I wanna point this out because you're really close, but don't make this mistake. It's actually called a convenience sample. I'm gonna type that in the chat box so you all see it. So it's C, and I'm also gonna say it so it's on YouTube. CONVENIENCE sample. Okay, so it's called a convenience sample. Don't make the mistake on your project or something to talk about convenient sample or on anything else that you do in the class. It's convenience sample. And convenience sample is, what that means is you just ask, and whoever decides to answer, sound good. Okay, and there's a problem with that. The problem with that is those people who answer often are going to be unrepresentative of the population. Okay. Now, I don't know well enough. Again, I don't expect I know everything, but I don't know, what kind of person would answer this. I do know that it's someone who looks online at the news. Okay. So it probably doesn't, and by the way, if you're elderly, don't take this in a bad way, but it probably doesn't represent the elderly as well. My mother and father tend to read on paper, and then they can't do the survey. To give you an idea, they still do newspapers. So it is going to underrepresent the elderly because they're more likely to read the newspaper as a paper instead of read it online. And they're not going to vote this way. It's also going to underrepresent the people that are a little bit shyer and don't want to click and be public, even though it doesn't have your name, but they worry. So it's going to underrepresent those people. And those people might be more interested, for example, maybe the elderly might be more interested in street repairs. Okay, I'm just guessing because they're worried about the streets. I don't know. But that would be a bias. So when you have convenience sampling, it's dangerous. There's often bias with convenience sampling. Any questions on that idea? Okay, now comes the hard part. Okay, what if you were in charge of this study? And now it's important and you want to get rid of as much bias as possible. Any suggestions on how you might do it? Because we decided that this didn't work. Any ideas on how you might conduct a survey so they don't have this kind of bias? Okay, go to door to door. Okay, that sounds like a good idea. There's some issues with door to door, by the way. First thing, especially in COVID times, a lot of people aren't going to answer the door. Also, you're going to find a lot more unemployed people and people employed at home than you are people who are working at home or on it. Does that make sense? Because if you go door to door, you're only going to get the people that are home.
Could you also collect demographic information?
Okay, and what are you going to do with the demographic information?
It'll at least give you a sense of who's taking the survey. And so you could compare sort of the differences in age or whatever information to the population you're trying to survey.
Okay. So I'm going to, I'll do it. I was going to do it later, but I think I'll state it now. You need actually more detail than that. Okay. And I think I'm going to pop into my, we're going to leave the survey, even though we're still talking about it, because you don't have to have the survey memorized. That's not important for the class. What's important is how do you survey your community? Okay. So some of you find a correlation. Correlation is a very specific word that we're going to talk about in chapter 12. We're not ready for that. Survey at the post office has similar issues with door to door. I never go to the post office. So that means they miss me and people like me. Okay, I put it in my own little mailbox and let the postman or post lady pick it up. So I never go to the post office maybe every 5 years to buy a whole big thing of stamps. So income, age, gender. Okay, but you got to be more specific in terms of how we're going to do that. Okay, go to the city council meetings. Then you're going to have a sample size of 1, like you screaming at the city council. And that happens a lot. Trust me, when I was on the board, I was on the school board, by the way, people would do that. They would come to our board meeting and say their piece, but we have to realize that it's not just them, it's everyone we have to hear. Okay, mail-in is good, except that have you ever received a mail-in thing and not replied? I bet most of you have.
Could you stand outside of a store since all kinds of people go to the store? Everybody has to grocery shop.
Yeah, which store?
A grocery store like Rayleigh's or Safeway?
Right, that's good, except you're going to miss the people who are a little lower income or cheap like me, and I go to grocery outlet because it's cheaper. Do you see? So you have to go to all of them.
You'd
Do you see
also
that? Because you got different. This is hard. I'm not telling you this is easy. I'm really not telling you this is easy. This is a hard thing to do. And of all things that you do in statistics, this is the hardest in reality. Okay, we're going to do a lot of math in this class. For you guys, that's going to be hard. But in reality, once you learn how to do it, it's not hard at all. But even when you know how to do this, this is hard to get a good study. So I'm gonna go and move to a Google Doc so I can start typing, because things that you need to remember. So the first thing is survey techniques, or let me go sampling techniques is even better. Okay, well, one we talked about, that was what we saw on this in this article, and that's convenience sampling. And convenience sampling is prone to many biases. Okay, so lots and lots of kind of biases that can happen. Okay, and we've talked about that. Again, it's in this case, it was you're only going to be getting people who are those who read the paper online and actually answer online survey questions, a very special kind of person for this type of convenience sampling. And that may have nothing to do with the overall population. Any questions on that? So never do this. Never use convenience sampling for a scientific study. Okay, and scientific does not mean like chemistry and physics. Scientific means you're doing it so that you can report it and you can say, I have confidence that this is correct. That's what scientific study means. Okay, doesn't mean science, by the way. Okay, or not the hard science, I guess. Okay, so that's one we already talked about. Now let me get into the demographic piece that some of you suggested. But there's more detail involved than you're making it. Okay, and by the way, that's the bad news for y'all because you got to learn the details. So the next kind of study, and it is the most commonly used study in regular sampling. And that study is called stratified sampling. In fact, let me boldface the names of them so you'll see that that's the name of it. Okay, so stratified sampling is a step-by-step process. So step one. Step one, what we need to do is you need to decide on the strata. So that's, for example, race is a strata that you may want to make sure that you don't have bias by. Okay, we don't want to only survey white people, okay, for example, or only survey Hispanics. We want to make sure that we have a good racial distribution. So race is one that's very typically done. What else do you think might be used for stratified sampling for people?
Age.
Yep, age is definitely one you would do.
Gender.
Yep, gender. By the way, do you mind, just to make life simpler for this class, if we kept it at male, female, so we can not keep writing different things? Is that okay? Or am I gonna get in trouble? Sometimes I can get in trouble for that, but just it makes life easier.
That's okay.
Makes life easier. If anyone minds, then I won't use gender, but because gender is real complicated otherwise. So we're gonna do biological gender. How's that? Okay, what else? There are others.
Income level.
Definitely income.
What about geographic location?
Good. Geographic location.
Education.
Education is definitely one that you might stratify by, depending on the survey question, all these things. Okay. And there could be others. How about political affiliation? Is another one. And I'm going to write, etc. Okay. In our class, this is elementary statistics, just let you know that is the name of this class. So any example that I'm going to have you do or I'm going to talk about will use a single strata. So it will be, I'll stratify by age and I'll talk about how to do that. Okay. In the real world, you typically do multiple strata, but it's just a lot more complicated to talk about. And that would be more of an advanced stats class. So, but I do like to give you a heads up that it can get more complicated than what we're doing. Okay, so that's number one. Number two, there's a number one, there's got to be number two. So we decided on the strata. Number 2 is research the percent of each group in the population. When I first taught this class, that used to be really hard. Now it's easy, really easy. So how do you usually research it now? Social
Online,
media.
would you use, yeah,
Probably not social media, actually.
well, you can use the census, right?
Yeah,
Or just ask.
I use Google. And Google will send me to the census, or it'll send me to whatever organization has actually determined this.
I have a question just to clarify. Research the percent of each group in the population. By each group, you mean whatever strata you use.
So for example, if you picked race, and we're talking Tahoe that way, because I know Tahoe real well, then in Tahoe, you would want to look at Caucasian, Hispanic, and other, because that's what Tahoe pretty much is. We're mostly Caucasian and Hispanic. Okay, there are of course some African Americans, there's some Asians, but we're pretty Hispanic and Caucasian, group in terms of, I think it's more than 80%. So what you do is you go online, you'd find out what percentage of Tahoe is Caucasian, what percentage of Tahoe is Hispanic, and what percentage of Tahoe are other. And I could probably do that in 30 seconds because Google's good about that. Okay, I could even ask Alexa, she'll tell me. Okay, and that will do it. So that's what I mean. When you've decided the strata, and the strata might be race, and then you look at each group within race, and then find the percents. Any questions on that? Okay, number 3. So number three is the math part, which is the easy part actually. Multiply the percents by the sample size to establish quotas. Okay, so for example, if you had enough time to do a survey of 500 people and you found out that 30% of Tahoe were Hispanic, then you'd take 30% of 500, which is 150, and you'd have a Hispanic quota of 150. Any questions on that?
Say that one more time.
Okay, so as an example, let's suppose, and by the way, don't quote me that it's 30%, I'm just making it up.
Sure.
So let's suppose that 30% of South Tahoe residents were Hispanic. Okay, that was number 2. And let's suppose you wanted a sample size of 500. You take 30% of 500. Okay, and you're always allowed a calculator, but they call me a human calculator, so that's 150. You get 150, and that's your quota for Hispanics. Okay, so step 4. Step 4 is survey the number of people determined from step 3. So again, if in step 3 you found out it was 150 for Hispanics, then you go out and you survey exactly 150 Hispanics. And if you ask another person and they say you're Hispanic and you've already got 150, you just say thank you for your time and you don't even ask the question. So you keep going until you get that exact number for each of the groups. And that's stratified sampling. Okay, is there bias in stratified sampling? What do you think? Definitely. Okay, there is bias in stratified sampling. That doesn't, getting no bias is usually impossible. But what you've done is, like in my example, you've eliminated racial bias. But there's other biases. So voluntary response bias is a very important bias that happens very often. Any guess on what that is just from the sound of it? Voluntary response bias?
There's only certain kind of people in the world that are willing to respond to a survey.
Yeah. In fact, have you guys ever gotten a phone call and didn't answer it?
I always
You
hang
didn't
up.
know who it was, or you didn't want to answer their survey? You politely hang up. We've all done that. Okay. Yeah, always. So again, if you're one of those always people, then that means you are not part of the study. Okay. You used to do the job of calling or the job of hanging up? Market reading. Oh, you did. Okay. I figure I should tell you, one of my very first jobs I ever had was market research calling, just like you did. Any guess how old I was? It was for a big company, a somewhat big company.
18.
No, the hint is I'm pretty old now, which means rules were different then. I was 11. I don't know how. Nowadays they go to jail, but I needed the money, and it was kind of cool. Now I'm teach statistics, so I actually understand this really well from when I was 11 about how surveys are and voluntary response bias and all this stuff. Okay, and I did what I did. Okay, any questions on stratified sampling? Okay, let me get the next kind of sampling, and that is cluster sampling. All right, so let me give you an example where you would probably use cluster sampling. Let's suppose, what if someone pays you to do a survey? That right, paying to a survey helps reduce voluntary response bias, actually. That helps, because in fact, that happened to me once. I got a call saying, we'll give you $100 if you answer the survey. Not even if you're lucky, you'll get $100. What do you think I said? Absolutely.
Please.
That's the easiest $100 I ever made. I answered the survey and they gave me $100. It was great. And they gave me lunch. So it was even better than $100. Okay, so that can happen. And again, but the problem with that is it's expensive. So if you're running the survey, you got to pay for it. So let me talk about cluster sampling. And there's a bunch of examples. I'm gonna kind of talk about a few examples. So one of them, let's suppose you work for the Forest Service. And let's suppose, I don't know, you want to find out the height of pine trees in all of the Sierra Nevadas. Okay. Any guess on how many pine trees there are?
Too many to count.
Yeah, a lot, a hell of a lot. Millions, definitely. Maybe more than millions, but a lot. There's no way you could do the height of every tree. So you're going to have to decide which trees you're going to look at. Is there a voluntary response bias? No, a tree isn't going to say, I'm not going to let you know my height. You can measure a tree. What's the problem? Why is it a
Deciding
challenge?
what tree to,
You have to choose, and how big are the Sierra Nevadas? Yeah, it's huge. Okay, we're talking Sierra Nevadas go for hundreds and hundreds and hundreds of miles. Okay, so the problem is which trees do you pick? Okay, so you could do stratified sampling, but the problem with that is if you did that, you may end up only going to Tahoe and looking at the trees there, which might be different than, say, down in Southern California, which is also Sierra Nevadas. So what you would probably do is you do cluster sampling. And in that case, what you would do is you would select maybe, let's say, 10 representative acres in different ecosystems throughout the Sierra Nevadas. Okay. And then you go to each of those 10 acres and you would measure every tree in each of those 10 acres. So logistically, that's not too hard because you'd have to travel to 10 places. Okay. And that's something you could probably do. Okay. If you're like me, that's fun. I like hiking. But that's something you can do is you can do that. And you could even randomly grab acres, but probably better would be to representatively grab acres. So you'd have some that are higher elevation, some that are lower, some southern, some more northern, you know, some on the eastern, some on the western. So you'd probably do it that way instead of random. And that's how you would do it. And that way you don't have to go, you know, all over the place. You just go to 10 places and you're done.
I have a question. With cluster sampling, you know, we're using the example of trees, you know, in the Sierra Nevadas. So, you know, you can, like you said, pick random acres and whatever. If you were going to be using this with people, would you do like geographically
great. So
or
let me give you-
demographically?
Okay, let me give you a great example with people that it's done all the time. And that is very specific people that all of you are part of those people, and I'm not, by the way. It used to be. And that is students. Let's suppose you wanted to sample California community college students. Do you know how many California community college students there are, by the way?
A lot.
About 1.5 million. Okay, you can't get them all. And by the way, in this class, we'll realize you don't get everybody. That's not going to happen. Okay, you have to do a sample instead of doing a census. Okay, census is almost impossible. Okay, for most populations. Census means you got everyone. Sample means you got a collection. All right, so here's how they do cluster sampling with community colleges. Is you select sections, classes, like maybe this class here, maybe a class in, I don't know, Santa Monica City College, and maybe you're going to do an art class in Santa Monica City College. Okay, so what you might want to do is you might want to get a representative group of classes from each of the colleges that you want to look at. Does that make sense? Then you go to the professor and you tell the professor, give the survey to your students. By the way, is there any voluntary response bias in this case?
Not if they want a good grade. No.
It's not about good grade, but it's a cultural thing. If I told you, especially with face-to-face, if I told you, you know, here's the survey, I'm giving it to you. You have 5 minutes during class, you need to answer it. You're all going to answer it, right? So it turns out you eliminate voluntary response bias with using this class-based system. Class as in course.
So I have a,
and that's
sorry.
cluster sampling.
I have a question. Let's say, for instance, I wanted to know if California community college students were, what's the word I'm looking for? Pleased that they went to community college prior to transferring, right? Could I do?
That'd be much, much harder.
Could I do like, can I go to 10 community colleges across the state and ask 10 students randomly, or would it be, okay, so I wouldn't want to do cluster sampling for that.
So you said prior to transferring.
Yeah, like, you know, or yeah.
Yeah, so you'd probably do that, and you would probably go to transfer courses and not non-transfer courses, right? There's no need to go to a, you know, some kind of like just fun afternoon cooking class or, you know, kayaking, right, something like that. So you're probably going to take this class, for example, English 101, and you would probably go to, and you would probably make sure that you represent the population by going to maybe San Francisco City College, a couple classes there, you know, a class in Tahoe, maybe a class in Merced College.
Right. Okay.
You know, so you want to go to representative classes so that you're representing the whole population. Does that make sense?
Yes. Do you have to take into consideration the population of each area as far as your percentage that or your quotas that you're going to try to get, or could you say 10 students from every college? Or
you wouldn't do 10. You probably wouldn't do 10 students from every college if you wanted to find out what percentage of the entire student population, because you'd want to do more San Francisco City College than you would do in Lake Tahoe Community College, because they're like 50 times larger than we are.
Right, so you still want to represent the population
Yeah.
in numbers. Okay.
Yeah, so you probably find out how many colleges there are that are the large colleges and how many students there are, and you'd kind of you'd use the stratified idea to pick your clusters. Does that make sense?
Yes, okay, thank you.
Yeah, so let me write down what cluster sampling is. So cluster sampling, what you do is first partition the population into many groups. And that could be acres. It could be classes. It could be, I don't know, states, as in state of the United States. There's lots of different groups that you can do. Okay, states probably not. They need to be small enough that you can ask everyone in a group. Then select representative groups and survey every individual in each representative group. Okay, and you do that like with classes, it's very easy. You just survey everyone in the class. With acres, you look at every tree in that acre. Does that make sense? And that's cluster sampling. Any questions on cluster sampling? Okay, let me get to the next sampling. So the next sampling is, this is done in manufacturing. So let me give you an example that I did, it was some years back, about 7 or 8 years ago. It was a former student of mine that went into business and had a big company, and he made towels. Okay, sorry if it's not that interesting, but it's interesting to me because he was my student. And he wanted some help from me to be able to sample his towels, basically to show that his towels are better than the made in China towels. But he couldn't sample every towel to find out if it was going to make it through wear and tear, because then he has no towels left to sell. So he needed to sample towels. Does that make sense? So what I suggested is that he looks at, over the course of however long, like 6 months or something of production, how many towels are coming off the assembly line. Let's say there were 2 million towels off the assembly line. And he wanted a sample size of 2,000. So then what I told him is grab every 1,000th towel, okay, off the assembly line, and that'll be your sample. So this especially works in manufacturing. And this is called systematic sampling. I'll tell you another way it can work also. And that is, make sure you have the population ordered. Then select every nth from the population. Survey. And again, nth could be every 1,000th, it could be every 10th, whatever works for your sample size. Okay, this is done with people sometimes too. Sometimes what they'll do is maybe every 100th customer in the store, they'll say, hey, I'll give you $10 if you answer this survey. So they're going to say yes. Most people will say yes to $10, right? Especially a short survey. And then you're getting a unbiased sample, okay? Or usually unbiased. Any question on simple systematic sampling?
How does that differ? Well, I guess, it's not random. Let's say you ordered the population and you took a certain amount of random numbers. So maybe
that's the next one. We'll do random next. Yeah, random is our next one, which is different than systematic because it's every 100th one is not the same thing as random. Does that make sense? Because it's just different, because random has a very specific meaning. But you want to see what random is now? Okay, so let me see. I like to test everyone to see how they do. let's see if you can pick, I want you to pick a number, a random number, okay, off the top of your head, a whole number from 1 to 10. And don't do anything, don't put it in the chat box yet. Okay, I want you to write it down on a piece of paper or have it in your brain. Get a random number from 1 to 10. When I count to 3, I want you to put it in the chat box. 1, 2, 3. Okay, so if we had true random numbers from 1 to 10, then there should be, each one should be represented 1/10 of the time. Is that true, by the way?
27.
How many 5s do you see? Do you see any 5s? None.
No
Okay, you
5.
almost never see a 5, by the way. It turns out, I don't know if any of you are psychology majors, but it turns out psychologically we do not have the capacity in our brains to pick a random number. Okay, we just can't do it. So
Yeah,
you may
I pick 7 every single time.
You pick 7 every time.
Every
yeah.
time.
Yeah, that's my lucky number 2, by the way. To tell you why, today is my half birthday. So you can figure out when I was born and what my birth date is, my birth month and day. It's 7/7. So I like
a very
7.
merry unbirthday to you.
Huh?
I said a very merry unbirthday. With what's her name? Alice in Wonderland.
Oh yeah.
Mad Hatter.
Okay. Anyway, so the point is you can't just pick a random number off the top of your head. So if you want to pick a random number, how should you do it? It's actually really easy nowadays.
Put it
Yeah.
on.
Ask Alexa.
Oh,
Or use my random number generator. Trust me, those work, by the way. Don't use a person. Google works too. Yeah, Google, Alexa, random number generator, and that will work. And you'll get a random number. You could use a die, that's the old style. 10-sided die, they're hard to find. Good luck finding a 9-sided die fast. There are no such things. Okay, so random. So the warning is, first thing, you can pretty much almost never do it. And you'll often see it reported in the news that they did it, and there usually means they don't understand statistics. So random means every individual has an equal probability of being selected. An individual doesn't have to be a person, it could be a tree, okay, whatever you're selecting. So there's all kinds of issues for this. How would you randomly select, let's say you wanted to randomly select 100 Americans. How would you do that? Any ideas?
With a computer
Okay, what would you tell the computer to do?
to randomly pick people from it.
Okay, you can ask Alexa, randomly pick 10 people. Do you think it can? Okay, voter registration. Good luck. Not everyone's registered. That's a problem. Okay, especially children. Yeah, so the answer is you can't. Okay, Social Security number, you get arrested if you go and harvest everyone's Social Security numbers. You'll go to jail for that. So don't do that.
Thank you.
Yep. So the answer is you can't. So random is almost always impossible with people. Okay, only with kind of smaller populations can you do random. So you can maybe randomly pick 5 people from our class, because you can list our class and then let a computer pick 5 people. Okay, you order them numerically, have a computer pick the 5 numbers, and you pick those people. That could work. But when you have large samples, like people in America, no way. It's not going to happen. Okay, or even trees in this Sierra Nevada, not going to happen.
So
Okay.
if you, for instance, put out a request, for people to volunteer for a survey and you got 100 volunteers,
Mhm.
can you randomly choose 15 of them to actually give the survey versus like a, placebo survey or something like that, like where it is completely random? Is that how you would do it?
So the problem is you're going to then you're randomly selecting from the volunteers, but you still are only selecting volunteers.
Right. So there's the bias. Okay.
And then you still have voluntary response bias. And then it's convenient. It's basically convenience sampling. Do you see that?
It seems to me, and I realize that I'm incorrect here, or maybe I'm not, I don't know, but systematic sampling, like if I pick the fifth person, every fifth person, that seems to me like it would be random, but is that just my layman's?
All right.
like-
How would you do that in America?
Right. I can do it in my town for an hour.
Probably not in your town, unless you live in a town like I grew up in. I had 200 people in my town.
Yeah. I mean, like in front of like you said, like earlier, in front of a grocery store or something, and then, went to different demographics.
Right. But that's
different-
still not random because you're only picking the people walking out at that time of the grocery store. Do you see?
Yeah. So it
Yeah,
just
so
is
random
infinite.
can never be done for large populations. Okay, I'm going to write almost. So for example, it can be done in an authoritarian society. So China, for example, because the people don't have rights there. So the government can go and get the person's personal information, but not in America, because we have all kinds of rights of privacy and stuff. Does that make sense? So it's not going to happen for most large populations. Any questions on that?
So when we see a random survey or a random, group of people, blah, 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 that's just them using semantics to try to make people
Yeah,
understand.
Usually, what it usually means is that they randomly selected telephone numbers to call. But what's the problem?
Hang up.
Yeah, most people hang up, so it's not really random. Okay, the initial group that they tried to ask was random, but the survey itself is not random. The participants who actually answered is not random. So worry every time if it says random, worry. Does that make sense? For any large population.
Right.
Okay. Again, I could randomly select students in my class. That wouldn't be that hard. Do you see that? But good luck getting everyone in South Lake Tahoe. You can't do that. Any questions on this? Okay. Then there's simple random. And I'm just going to briefly talk about this, a little more complicated. Simple random is a special kind of random where you're doing it by groups and then everyone in the group. So that's kind of like a mix of, it's a mix of stratified and random. So sometimes called stratified random sampling. And this is, sorry, not simple random. Random, but not simple random. And what that does is, let's say you could get a list of the whole population, but you still don't want to get unlucky and maybe have too many Caucasians. So then you stratify by, you kind of put them into groups by race, and then stratify, but the way you pick each strata is by random, each person in the strata. The way you get your quotas is with random. Okay, so it's a little more complicated, and I'm not going to spend much time on it. Sorry about that, but we only have so much time. Any questions on these different ways of collecting data?
What is the most effective technique then?
So what do you mean by effective? Effective meaning not too hard and then people do it? Or
No,
If you had an
without
infinite amount of
The
money,
most efficient.
the most efficient,
most
without the
efficient is
most
the-
biased.
okay, so the most common is stratified. So stratified is most
Scientifically,
Huh?
scientific, like scientifically, that would be the most common.
That's the most common, and they typically do many strata, not just one, because you can do it. You know what I mean? It's not that hard to get the. It's not that hard to do these steps. Does that make sense? These steps are very doable. So stratified is the most common. The other one that's real common and bad is convenience sampling. You'll see that a lot. And again, you should always, worry about it. Then there's some other special kind of sampling. And if you're doing, especially in medicine, and I know we have a lot of nursing majors, okay? If you're doing a test on the vaccine for COVID, then what you're going to do is you're going to do maybe half the people get the vaccine and the other half of the people get a placebo. And you do what's called a randomized control study. And a randomized control study means that you get a bunch of people, bunch of volunteers typically, and then you take those volunteers, you order them in a long list, you have a computer select half of them to be the treatment group. They get the vaccine. And the other half typically thinks they get the vaccine, but they didn't. And even the doctor doesn't know they're not giving the vaccine. Does that make sense? And that's a placebo. They get a placebo. And that's how they did all of the COVID trials, is placebo. Okay? Yeah, and if the doctor doesn't know or the nurse doesn't know, it's a double-blind study. Exactly. And that's real common, especially in medicine. So do you think I've ever been part of that?
Yes.
Yes, it was horrible. There was an article that says, if you have the runs, run to the VA center and be part of our study. And I was having a bad day, if you know what I mean. And I was a placebo and I didn't get better. It sucked.
So in a double blind, when the doctor or nurse, it's who's administering it. They're the ones that don't know. Who's keeping track?
The researcher.
The researcher. Okay. So the doctor or nurse, the administrator doesn't know what they're giving.
Right. All the administrator has is a serial number of the medicine or not
Okay.
medicine.
Okay.
So they don't know what that serial number means, but the researcher knows. So the nurse writes down the serial number and then writes down what happened. And then the researcher gets to see that. The researcher knows what that serial number means. The doctor and nurse doesn't.
And they have the person who's receiving its information or whatever to correlate or
Exactly. And the patient doesn't know either. They don't know until later that they were the placebo or the control. Okay, any questions on that? Okay, I can't get into every detail. I hope you understand that. But I do want to talk, that's a real important study, especially in medicine. Okay, and you can't always do double-blind studies. Okay, sometimes it's impossible. Sometimes there's ethic reasons. So for example, let me tell you a study that was done when I was a college student that you can't do anymore. And that is, my friend was involved in this, is they had a party and they got people really drunk with alcohol or with the placebo alcohol, fake beer. And then they watched to see what happened. Okay. Nowadays, you can't do that because of ethics. You're not allowed to make someone drink 10 glasses of beer. But in those days, you can do almost anything you wanted. Okay. So things are different now because of ethics than when I was, younger. But so you have to be careful. Okay. What days were those? The 80s. That was the 80s. Okay. So the longer back you go, the fewer ethics there were. So nowadays, it's really hard to do that kind of study. Okay. That was a blind study. I don't know if it might have been a double blind study, actually. because the person didn't know if it had alcohol or not, because they made sure it tasted like beer. And my guess is the person handing the bartender didn't know either. Does that make sense? They probably had a serial number. Okay, so that's an example. Let me give you an example of a comparison study where you couldn't do it. There's no way you can do a any kind of blind study, okay, or a placebo group type of thing, or even any study. And that is, if you wanted to see what the consequences are of beating a child and to see what happens when they grow up. Okay, what's the problem with trying to do a study? Maybe a blind study.
Unethical.
Yeah, so it's unethical. First thing, you can't be blind because you know if you beat your child. No such thing as not knowing that you beat your child. Does that make sense? You also can't randomize control it because you can't say, hey, you're a parent and we're gonna you have to beat your child because your number was odd instead of even. So you have to beat it. You just can't do that. So many times you can't do that kind of study. And those are hard to do. And it's really hard to do statistics. So I want to kind of, not give you all the answers, but give you the questions. Any questions on any of these before I move on? Okay, let's move on. Now I'm going to do a survey of you because we need data. And let me go. I'm going to use my spreadsheet program because I want to do pictures also. That's that guy. And the way I do it, by the way, the first thing I'm going to do is I'm going to erase all of these guys. By the way, after you have made sure that you made a copy so that you have your own version of this program. So I just highlighted it and backspaced it. And let's do a study. First thing we're going to do what's called quantitative data. Very important to know what that word means. What do you think quantitative means?
Numbers.
Numbers. So the Tahoe Daily Tribune survey was not quantitative, right? Street cleaning is not a number. Okay.
Qualitative.
Yeah, so that's qualitative. So there's qualitative and quantitative. So quantitative is better to do analysis because you do math with numbers. So is there anything that you're interested in about each other that's quantitative? Don't take too long.
Age.
Okay, age. Okay, so here's what we're gonna do. A major would be qualitative. I was a math major, and that's not a number. Okay, so age works. Okay, so I want to tell you the rule of the class. So the rule of the class is, the first thing is if you put in the chat box is not part of YouTube. So only you guys can see it. If you don't feel comfortable stating your age, then you can state an age that is reasonable. In other words, I'll let you lie, but don't say 784. That's not a reasonable age, okay? So I want you to put your age in the chat box. And if you don't feel comfortable, put an age in the chat box. And one of the problems is we have so many people, it's gonna take a long time to type these all in. So let me start typing. Okay, 51. I tried to make this easy, by the way. 28, easy to enter data. 21. Oops, wrong one. 28, 25, 28. 26, 24, 17. 27, 17, 28. Let's go more. 40, 40, 19. Let's do some more. 24, 27, 21. It's really hard to scroll down when there's so much there. But that might be it. Okay, so that's all of I got. Sorry if I missed one, but that's okay. Can't be perfect. All right, what I want to do now is I want to look at this stuff. First thing, as I mentioned, this is a quantitative variable instead of a qualitative. Quantitative means it's a number answer. Qualitative means it's a word answer. There's a special kind of qualitative that we're going to be doing a lot of, that you see a lot, and that is yes, no. I don't think I need to explain what a yes, no question is. But that's a special kind of qualitative. It's also a word, but it's very special. This is qualitative. And since my guess is you all rounded to the nearest whole number, okay? I'm a geek, so if you ask my age, I would not have given anything like what you said, especially since I'm proud that today I'm actually 54.5, exactly. Okay, 30 minutes ago I was. So just to let you know, so this is called, it's called discrete if we're only looking at, for example, whole numbers, and it's going to be discrete. Later on, we're going to have chapters on discrete versus continuous, and I'll talk about that in more detail. Okay, so then what we're going to do is say, well, is this data from a population, or is this data from a sample? What do you think?
Population.
Okay.
Sample, it's a class, right?
Okay, so what I want to say is it depends on your frame of reference. Okay, given, and I didn't check, but given everybody answered it, if I'm thinking of the population of everyone who showed up in this webinar, then this is data from the population. If I'm looking at this as a representative sample of statistics students that are online, then this is a sample. Does that make sense? So it's a frame of reference thing in this case. Usually it'll be obvious. This one's not obvious, but I like this example because I can say both. If it's a population, then these numbers that you get, like minimum and mean, those are called parameters. Can you remember that word? Parameters. I'll put it in the chat box. Come from a population. Okay, if it's from a sample, then we call them statistics, which is the name of the class. Come from a sample. So there's a sample statistic, there's a sample mean, there's a population mean. There's a sample standard deviation, there's a population standard deviation. It turns out with standard deviation, there's actually a different formula depending on whether it's population or sample. And so in the spreadsheet, if you scroll down a lot, you'll see population standard deviation, and you'll get a different number, 8.4182-ish and 8.6623. So slightly different. Okay, with the mean, it's the same. With most of them, it's the same. But with the standard deviation and variance, sample and population matter. Okay, in terms of the number you get. All of them matter in terms of what you're talking about. All right, so I want to go through each of these statistics. Okay, let's call them statistics. Let's think of this as representative of all statistics students and maybe, I don't know, community college stat students that are online. I'm hoping I don't have to spend a lot of time talking about what it means to say minimum. You all know what that is? Hopefully. Okay, what's a more common word if you want to talk to a 7th grader for the word mean?
Average.
Average. Okay, so the word mean is the same as the word average to the general public. But for our class, we need to use the word mean. Any questions on that? Okay, the variance we're not going to do much with in this class. That's more advanced. I'm going to stop it and just say it's a number. The only thing different between the two, do you mean the two meaning sample versus population? Yeah, that's going to be variance and standard deviation. And that's why in my spreadsheet, it actually says SAMP to remind you, hey, this means a sample. Okay, So the sample standard deviation is 8.66-ish. Okay, that is a very important number. Okay, one of the most important numbers there is in this whole class. Okay, and you might have heard of the word standard deviation. What it does is it gives you an idea of how spread out the answers were. So it's kind of an average distance from the mean that the answers are. It's not quite mathematically, but that works for this class.
Does that mean the distance between each of the ages individually?
Yeah, so for example, the first person said 51.
Okay.
The mean was 27. Okay, that's 24 away from 27. Do you see that?
Yes.
So that one actually is pretty far away, much, much more than a standard deviation or even 2 standard deviations.
Okay.
And in fact, if you're more than 2 standard deviations away from the mean, we call it an outlier.
Yes.
Okay, and that's the definition of an outlier. It means more than 2 standard deviations on either side of the mean. Okay, any questions on that?
So yes, I need to verify this, or I need to clarify it because this was part of something that I had a hard time understanding in previous classes.
Mhm.
So the mean is 27, which is right in the, or is the average. Okay. the
And I'm
mean.
rounding to the nearest whole number.
Okay. So 8 being the standard deviation.
Or let's call it 9 if you want to round. Let's do.
Okay, 9. That would put us at 36 and 18. No. Right? I mean, is that what I'm understanding? I'm
So
trying to understand what the 8,
Okay.
what the 8 or the 9, 8.66 represents.
So it tells you a kind of an average distance that the data values are from the mean. So 51 is 24 from the mean. 28 is 1 from the mean. Do you see that?
Yes.
21 is 6 from the mean.
Yes.
Okay. Basically, if you take the average of all those differences,
Okay, so it's like the mean of the differences.
yeah, it's not
Okay, thank you.
exactly that. So I'm not going to, the formula is kind of messy and I don't want you to deal with the formula. You don't have to worry.
Okay, that's okay. I just I need to understand a little bit in my brain. So thank you.
Yeah, the formula is slightly different than that. And there's some heavy math for the reason I'm not going there. Okay. Because you guys don't have a calculus requirement. So at this point, just trust me. Sound good?
Okay, thank you. Yes, but that clarified it for me. I hope it maybe clarified it for others, but that helped me. Thank you.
If you want to find out how many standard deviations it is from the mean, and I'm going to round, so 27, 9, and 51, then we call that the z-score. So if I type in 51 for the value of x, the z-score is 2.7. So it's 2.7 standard deviations above the mean. Any questions on that?
Yes, can you please repeat that?
Okay, so the z-score tells you how many standard deviations above the mean the value is.
And the value is
51 in this case, because I wrote 51.
okay. So
If I change this to 21, then that's negative 0.7.
and the z-score is compared to the standard deviation.
The z-score tells you how many standard deviations away from the mean this value of x is.
Okay.
And if it's below, you get a negative. If it's above, you get a positive. Okay.
Okay.
Now, it's very helpful to have a z-score. So let me give you an example. My SAT math score, okay, I took the SAT, was 1,490. My daughter's SAT math score, I'm sorry, my SAT score, not math score, my SAT score was 1,490. My daughter's SAT score was 2,200. Okay, who did better?
Your daughter.
Okay, and the answer is you don't know. One thing you do know, unless you're just stupid, is that my daughter's younger than me. I hope you all know that. A lot younger than me, right? More than 6 months younger. Okay, the point is that when she took the SAT, it was a total different generation than when I took the SAT, right? And it wasn't even the same number out of the same number of points. Do you agree? Do you believe me at least?
We believe you.
So if I tell you my SAT score and I tell you my daughter's SAT score and I ask you whose is better, you can't tell me. You have no idea. Does that make sense? But if I tell you my SAT score, my Z score for my SAT score was 2.7, and the Z score for my daughter's SAT score was 2.9, who did better?
You did.
By 0.2.
No, my daughter did. She had the
Okay.
higher SAT. She had the higher Z score.
Okay, so that's not the space between.
Right. She did better. She had a 2.9 Z score and I had a 2.7. Okay. So by the way, if you get a 2.9 for your Z score, what university do you think you might go to? Or college? Okay, possibly Harvard. Yeah, she went to Berkeley. Okay, and you need a high Z score for Berkeley, by the way. Okay, if you get 2.7, then you still go good, but you wouldn't get into Harvard. Does that make sense? Okay, I went to UC San Diego, by the way. So Z score really tells you how you're doing compared to everyone else. Any questions on that? UCSD is awesome, by the way. The surfing is amazing. The skiing sucks. Just let you know that. So I hope you don't love skiing because you're not.
Well, you can go water skiing.
Yeah, I'm talking about snow skiing. Yeah, but the surfing is awesome. I body surfed every day there. Okay. So anyhow, so that's the standard deviation, very important. The median, you probably heard that before. What is the median? That you get in 5th grade, you may not remember it anymore.
It's the very middle number.
Yeah, it's either the middle number or the average of the two middles if there's an even number in the data set. Right? So it's either the middle number or the average of the two middles. Okay, so it's 26.5. Okay, notice the median is less than the mean. Okay, the median and the mean give you different pieces of information. The mean is influenced by outliers and the median is not. Any questions on that? So for example, if you wanted to kind of understand the typical price of houses in Tahoe, do you think you'd want the mean or the median? What do you think? Okay, I'm seeing both in the chat box. You'd want the median. Okay, if you don't know Tahoe, then I understand a little bit, but it's actually true in most cities, but Tahoe especially. In fact, 2 of the top 10 most expensive zip codes, for example, are in our Tahoe area, and I talk most expensive in the whole country. So we have these super outliers. We have an $85 million house for sale. Okay, and what happens is that's a super outlier, and that's going to just skyrocket the mean. And you're going to end up looking at the mean and saying, well, the mean is $1 million, but that's not the typical house. The median will give you more of the typical house. Okay, but the mean is very important for the city council. Okay, how come?
It represents or it increases like the demographic, right? The social
I
economic
like what Leanne said. Taxes.
taxes.
Yeah, that $95 million house, they pay a lot of taxes. Do you see that? And their budget, the city council's budget is based on taxes. So they care more about the mean if they're worried about their budget. Any questions on that idea? So the mean and the median are both important, but they're important for different reasons. Okay, I think the maximum you all understand, am I right? If you have questions, tell me now, but I think you get what that is.
I have one. I'm so sorry to do this to you because I know you already went over it with me. But so the standard deviation, you said if it's over 2, there's a lot of outliers. So does that mean
Not if the standard deviation is over 2. If the z-score is over 2, it's an outlier.
Oh, okay. Thank you.
The standard deviation just tells you how spread out the data is.
How spread out the data.
So
is.
with the standard deviation of 9, it's not that unlikely, for example, to have an age of 19. Because 19
Okay.
is 8 away from the mean, and that's not even a standard deviation away. So that would be pretty likely. Do you see that?
And yes, and the z-score is representative of a specific value, so you can see the outliers versus the ones closer to the.
Right.
to the
So let
mean.
me give you an example. Let's suppose I told you my goal is for most of you to pass this class. Okay, I want the vast majority to pass this class. Let's say I told you that the average score on the final exam was 75%. Did I reach my goal?
Yes.
Okay, it's a trick question. You have no idea. Okay. If the standard deviation was 1, then almost everyone passed the class. Maybe everyone passed. Because if that would be 5 standard deviations away to get under 70%. Do you see that? If the standard deviation was 20, there's going to be a huge number of people that got below 70. Does that make sense?
Yes.
Because the grades are all spread out. Okay, if the standard deviation is 1, everybody got a C. Yes, you all passed, and maybe you want the A, but my goal was everyone passes, so I got my goal. Do you see that? If the standard deviation was 20, then there's going to be a bunch of A's, B's, C's, D's, and F's. Do you see how that works? So the standard deviation tells you how spread out everything is. Okay, let's unfortunately I did this and I can't change it. I'd have to reprogram the whole thing. Q1 really should be next, not Q3. Q1 is called the first quartile, and it basically says, like the median says 50% is below and 50% is above. Q1 means 25% is below. So 25% of the class is under 21.75 years old. Q3 is the 75th percentile. So that means 75% are below 28 years old. Any questions on that?
Can you
Okay.
please repeat what the Q1 was?
So Q1 is the 25th percentile, 25% below, at or below.
Thank you.
And I will tell you this, and this is the most frustrating thing for me of all of statistics. And I just want to shoot somebody. There is no mathematical definition of the quartiles. It sucks. So if you use Excel, you're going to get a different answer than if you use, let's say, a TI-84 calculator. And that will be a different answer than if you use the homework system that I programmed it with.
What did you just call it?
Huh?
A quart house?
Quartile.
A quartile. Sorry.
Q-A-R-T-I-L-E.
Got it.
Did you say that Q3 was 75%?
Yep, 75th percent.
Okay.
And Q1 is 25th. So quarters, right? 25 cents is a quarter.
75th percent
Yes,
or
we-
above? Or above
That means 75% are below that number.
or below? Okay.
So notice the third quartile, Q3, is a lot bigger than Q1. Q3 is 28. Q1 is about 22. Okay. So those are the quartiles. It cuts it into quarters. And in particular, we call the interquartile range the range in between Q1 and Q3. Sometimes you'll say 21.75 to 28. Sometimes you subtract the two numbers and say that's about 6.25.
Just to clarify, a Q2 would just be the mean, right?
Yeah, no one uses the word Q2 because not mean, median.
Oh, the median. Okay.
Median. But no one uses Q2 because you have the word median, and everyone uses the word median. Okay, we don't have that much time left, so let me get to pictures. So we're looking at a picture. This is the one that hopefully everyone understands because you've all seen histograms before, right? I hope so. So there's a histogram. And one thing to note that a lot of people don't know is that the x-axis has to be quantitative. You can't do a histogram of the Tahoe Daily Tribune example because that was qualitative. You could do it just a bar chart. But these are histograms mean quantitative. And the y-axis is always the number of yeses in those areas. So the number of people who are between 15 and 23 years old, there were 5 of them. Do you see that? Okay, between 23 and 31, there were 10. There was nobody between 31 and 39. There was 2 people between 39 and 47. Between 47 and 55, 1 person. We call this unimodal. What is uni? UNI. That's a prefix. What does that mean? You've seen it in other words. 1, like unicycle. Means
1.
So unimodal means 1 mode. Mode means high point, most frequent. What do you think bimodal would be, like bicycle?
2.
Bimodal. Yeah, that'd be 2 modes. Okay. You'll see that, for example, if you did kind of a large sample of heights of people. Why might that be bimodal? Any guesses?
There may be 2 heights that are.
I like Navi's answer. Women and men. Yeah, there's a whole lot of women that are around 5'4" and a whole lot of men that are around 5'10". That's why. So that tends to be bimodal. Does that make sense? So bimodal tends to happen when there's kind of 2 groups put into the whole population. So this is unimodal though. If it is bell-shaped, we call it normal. If it is just flat, like every bar is the same height, we call it uniform. Again, I'm saying a lot of stuff. Read the book so you get this down because we don't have much time. So that's called uniform if everything's the same height. It's called normal if it's bell-shaped. It is unimodal if there's 1 bar. It's symmetric if you cut it in half and left and right are mirror images of each other. That's called symmetric. It's called skewed right. And this one's skewed right if you have this mode and then you have a tail to the right. So you see this tail over here? And skewed left would be there's a tail on the left instead of the right. So there's all these words for the shapes of the distribution. I want to show you a couple more things since I only have 2 minutes. If I go to stat and I go to box plot and I wait a minute. Okay, this gives you another representation of the data. And this is what's called the 5-point summary representation, meaning there's 5 numbers it shows. The numbers it shows is 17. Any guess what 17 is? The what?
Minimum.
That's the minimum. 51 is the
Maximum.
maximum. 25 was the
Mean.
mean. 21 is the first quartile. And 27.5 is the third quartile. And sometimes you call it box plot. Sometimes you call it box and whiskers plot.
Oh,
It's got
yeah.
a couple names. You'll hear both. Yeah. So Devorah, you were asking. Yeah. Sometimes you'll hear box and whiskers. Sometimes you hear box. I have a whole lot of words down at the bottom. That's so that if you're blind, you can still read it. So if you're not blind, you don't have to worry about the words at the bottom. Any questions on this? This is really good for showing the interquartile range because in bright red, you can see that the middle 50% is between 21 and 27 years old. And that takes the half, the middle group. Do you see that? So each plot has something good about it. Why would you not do this for a big public presentation of just general public audience? What's the problem?
It's hard to read, like aesthetically, like the picture doesn't really show the up and downs of the histogram kind of.
There's that, but for the general audience, it's a bigger issue. That is, most people don't know what it is. They don't even know what it means. So
Right.
histograms are much
But-
better for general audience because most people can read a histogram and know exactly what it is. Most people don't even know what this is. But young people all know. Anyone know why? Or all supposed to know at least. Like 16, 17-year-olds in America. Okay, Common Core standards. It's now
I was gonna say Common Core, yeah.
it's now part of the Common Core standards. So if you're my generation or even 28 or older, then you didn't get this when you're in middle school. Now middle school students all get this. So it's now part of the Common Core. So that's a box plot. Okay, let me do the last plot. We might go a couple minutes over. Just impossible to do this in the amount of time. Sorry about that. Hopefully you're okay with that. If I go stats and I go stem and leaf. Okay, what this does is it shows all of the data values. And the way I've written it is I pop out the outliers. So we know the outliers are 17, 17, 40, 40, and 51. And the non-outliers are here. So we can see that the way you read this is the left-hand side of the tens digits, the right-hand side of the ones digits. So for example, I can see right away the mode is 28. Can you see that? Because there were 4 28s. Whereas in the histogram, you can't see 28 as a mode, can you? And in the box plot, you couldn't see 28 was a mode either. Okay, but you could definitely see the mode. You could see all of the data values. Okay, so the good thing about this particular plot is you can get back to the original data by looking at it. Can you envision some problems with it? Any ideas on some issues?
It doesn't seem to represent everything.
No,
does
this
it?
has everyone. This has everyone that was surveyed. See the outliers, they're there.
Oh, at the bottom, I see.
Yeah, yeah, this pulled out the outliers. Some do, some don't. I programmed it to pull out the outliers. Otherwise, it gets ugly if you don't. Sometimes it gets ugly. Anyone see a big problem? And the hint is it's not a big problem in this example. Okay, maybe I'll tell you. What if you had a data set of, let's say, 500,000 people? You couldn't do it. Do you see that? Because you'd have to have 500,000 numbers on this sheet, and you couldn't fit it. So this only works for small data sets. Any questions on that? It also does not, it scares away number files. You know number file is? Sometimes called number phobe. Someone who's afraid of numbers and they just get turned off when they see numbers. So that's another problem with it. But if it's a small data set and people aren't afraid of numbers, then this is actually a nice depiction. Secret word is statistic. So don't forget, go to your secret word quiz, and the word to type in is statistic. Okay, so that is, let me stop the share because we went over. And I'm going to say goodbye to the recording.